I'm Amakisina Balkis and I'm gonna answer for question number 1. So, what is differentiation? Differentiation is a fundamental concept in calculus dealing with the rate at which quantity changes. It is the process of finding the derivative of a function. The rate of change of function is defined as dy over dx equal to f prime x. Next, we will talk about 11 technique of differentiation. Number 1. Power rule. Power rule used to differentiate the power of x by bring the power down to multiply and subtract 1 from the exponent. This rule applies to positive, negative, and fractional powers. Number 2. Constant rule. Differentiating a constant always results in 0. Number 3. Constant multiple. When a constant is multiplied by a function, can factor out the constant and simply differentiate the function. Number 4. Sum rule. When functions are added, we can differentiate each term separately. Number 5. Difference rule. When functions are subtracted, we can differentiate each term separately. Number 6. Product rule. We use it when two functions are multiplied. Number 7. Quotient rule. We use it when one function is divided by another. Number 8. Chain rule. We use it when a function is inside another function. Number 9. Exponential rule. We use it for differentiating exponential functions. Number 10. Trigonometric rule. We use it for differentiating sine, cosine, tangent, and other trigonometric functions. And lastly, logarithm rule. We use it for differentiating logarithmic functions. And that's all from me. I'm gonna pass to my friends to answer question number 2.
Moving on to question 2b, we need to find the derivative of y equals x to the power of 4 multiplied by cos 2x cubed. Since this function is the product of two distinct terms, we will apply the product rule, which states that the derivative is u times v prime plus v times u prime. So for next step, we're going to differentiate u and v individually. Let's break down the individual derivatives. Alright. For the first term, u equals x to the power of 4, and its derivative u prime is simply 4x cubed using the power rule. For the second term, v equals cos 2x cubed. Here we must apply the chain rule. We bring the power of x to the prime, multiply by the derivative of cosine, which is negative sine, and finally multiply the derivative of the inner angle 2. Simplifying this gives us a v prime of negative 6 sine 2x cos 2x squared here, as you can see. And then for the step 3 is we're going to substitute into the product rule formula. Okay, so for next we substitute these components into our product rule formula. We take our original u term and multiply it by v prime, then add our original then we're going to add our original v term multiplied by u prime. Written out, this gives us negative 6x to the power of 4, since 2x cos 2x squared plus 4x cubed cos 2x cubed. And then we're almost there. So for now, we're going to factorize for the final answer. To complete the problem professionally, we factorize the expression by pulling out the highest common factors, which are 2x cubed and cos 2x squared. Inside the brackets, we are left with negative 3x sine 2x plus 2 cos 2x. Rearranging the terms inside the brackets to lead with the positive value gives us our final, fully simplified derivative. So for question 2, that's all. Assalamualaikum everyone, and now I will explain for the second question, which is find dy over dx for the following function. So for question A, we have here is y equal sine 3x over ln x plus 1 minus e. So for the first step is we should identify the rule. Looking at question 2a, we are given a rational function where both the numerator and denominator are functions of x. To find the derivative dy over dx, we need to apply the quotient rule, which is v times u prime minus u times v prime all over v squared. So for the next step, we should differentiate the u and v individually. Before plugging everything into the formula, let's find the individual derivative. For the numerator, u equals sine 3x. Applying the chain rule, its derivative u prime is 3 cos 3x. For the denominator, v equals ln x plus 1 minus e. Let me show you. The derivative of the natural log term is 1 over x plus 1, and then constant negative 8 becomes 0, giving us a v prime of 1 over x plus 1. And then, for the next step, we're going to substitute into the quotient rule formula. Now we substitute these components back into the quotient rule formula. We take our original denominator, multiply it by the derivative of the numerator, and subtract the original numerator multiplied by the derivative of the denominator. Finally, we place the entire expression over the original denominator square. And as for the last step, we're going to simplify it. So to present the final answer in its cleanest form, we can eliminate the fraction in the numerator by multiplying the entire top and bottom by x plus 1. This gives us our final derivative 3x plus 1 cos 3x times bracket ln x plus 1 minus e minus sine 3x all divided by x plus 1 times bracket ln x plus 1 minus 8 squared. That's all for question 2.
Today I will explain how to find dy over dx using implicit differentiation for the equation. For step 1, I will differentiate y power of 4. I'm bringing 4 to front and the exponent will be minus 1. I put dy over dx because it containing in term of y. For the second step, I differentiate tangent x squared plus y squared. I apply the chain rule twice. First, the auto function tangent, I differentiate tangent x squared plus y squared. I get a secant squared, x squared plus y squared. After that, I differentiate the expression inside the bracket that also requires chain rule and get to x plus 2y dy over dx. Next, I expand the bracket by multiplying secant squared x squared plus y squared with the h term inside the bracket. After expanding, the expression becomes 2x secant squared x squared plus y squared plus 2y secant squared x squared plus y squared dy over dx. For the step 3, I differentiate e power of xy. For e power of xy, I use the chain rule. Since the derivative of e is e itself, that means exy remains unchanged. Then I differentiate the exponent xy because it multiplies together. To differentiate xy, I use the product rule where u equals to x and v equals to y. The derivative of u is 1 and v is dy over x. This means that the derivative of xy is x dy over dx plus y. Then I substitute the result into the equation give e power of xy multiplied by x dy over dx plus y. Then I expand the bracket to get as e power of xy dy over dx plus y e power of xy. For the last step, I substitute and solve for dy over dx. I substitute all the differentiate term into the equation. Then, I move all the term that containing dy over dx on the left side and move the remaining term to the right side. Next, I factor out dy over dx on the left side and put s in the bracket. I make dy over dx as the subject and move the expression in the bracket to the right. This is the final expression for dy over dx.
Last question, question 4, which is use differentials to estimate the value of the value given in the question, then give your answer correct to 2 decimal places. So first thing first, we need to determine the value of fx. And then we need to determine the value of x and x naught. Next, we need to determine the value of partial derivative x. And then differentiate the value of fx. Next, using this equation, we can estimate the value given. So first thing first, how to search the value of fx. So just write the given value all over again, but what in the bracket becoming x. So it is written like this one. So for the value of x, as I said, it is the value in the bracket. For the x naught is the whole number closest to the x, which is 49 for this question. Next, we need to search for the value of partial derivative x, which is x minus with x naught. And then we got the value, which is 0.02. And then we need to differentiate the fx, which is the root number, is bring to the front like this one. And then the root number also need to be minus by 1. And lastly, we can use this equation to estimate the value given. To use this equation, fx naught is fx here, but the x is replaced by x naught, plus f prime x naught is f prime x, but the value of x is replaced by x naught also. And then multiply by partial derivative x, which is 0.02. Then finally, we got the answer, which is 328.21.